Hi there and welcome back to Mrs. Cadigan's tutorial videos. Today I'm going to be talking about how to simplify radical expressions. And before I get fully started in this lesson, I want to bring up some factoids, as I call them. Little facts that will help us along the way. First of all, let's recall that when we're looking at a radical with a number here, this is known as the index. And a is your radicand. And what we're asking when we have n root a is what can we multiply by itself n times in order to get a? And also, if we don't have a number there and we just have a regular square root, that is the same as having an index of 2. And because we're looking for a number that we can multiply by itself twice in order to get x. So it is a 2, we just don't write it. For these are old things that we should have picked up before, but if you haven't, here they are again. X to the a to the b is the same as x to the a times b. So if we take something that's raised to a power and raise it again to another power, we multiply the degrees together. X to the a times x to the b, so if two things have the same base raised to certain degrees, then the result is that same base raised to their sum. And finally, if we have two things of different bases and we multiply them, we don't do anything. It actually is the same thing. We cannot combine them. I just wanted to make that clear. Now, if x is bigger than 0, and we look at negative x raised to a power, if a is even, that negative disappears. If we multiply a negative by a negative, it becomes positive. So if we do that an even amount of times, it also cancels out. However, if I take a negative and I multiply it by a negative, I get a positive. If I multiply it by another negative, it will become negative again. So that would be a cubed, and that happens for anything that is to an odd power. So if I have a negative number raised to an odd power, it is going to be negative. And finally, we are looking at just real roots. We know that the square root of -1 is I, but when we're simplifying these radical expressions, we only want the real answers. We don't want complex answers. So we're going to kind of forget about complex numbers for a moment, and we're going to stick with the real roots of these problems. So when we're simplifying radical expressions, if we're looking at an index that is even, we need to consider the absolute value of it. This is what's known as the principal root. Because if we recall that when both -4 squared and 4 squared, they both equal 16. But for the sake of simplifying, I only care about the positive one. So when we're given something like root 16 equals, what we're trying to simplify is something like this. We just want it to be 4. However, if we're solving and we have x squared equals 16, when we take the square root of both sides and we're solving for x, we still need to consider x equals plus or minus 4. So this is simplifying and this is solving. There's two different ideas behind each. So for this chapter, we're just simplifying. We're not worrying about the plus or minus. So let's get started with an example of this. Note that this is only for an even index. So when we have something cubed, we don't consider the absolute value of it, because it goes back to this factoid that if we take a negative number and we raise it to an odd power like 3, we get back a negative number. So the cubed root of a negative number is never going to be positive. It has to be negative, because a negative times itself 3 times will get you back a negative. So for an example of this, let's consider for the fourth root of 16x to the 8th y to the 12th. So let's look at this for a moment. And for me, I like to see it simplified before I take it out of the fourth root, just to make sure that it is what I want it to be in the end. So I'm going to take everything and see if I can raise it all to a fourth power. So 16 is the same as 2 to the fourth. X to the 8th is the same as x squared to the fourth power. And this is because, remember, if you take a number and you raise it to a power and you take that whole number and raise it to another power, we multiply the exponents. And since 2 times 4 is 8, we know that these two are the same. And similarly, this y to the 12th is the same as y cubed to the 4th. And the fourth root is essentially the same as canceling out each of these fourth powers. But since this is an even index, we have to keep everything inside of an absolute value. So let's go ahead and put our answer in an absolute value. The fourth root of 2 to the fourth is 2. The fourth root of x squared to the fourth is x squared. And the fourth root of y cubed to the fourth is y cubed. This is close to the answer, but we're not quite there, because if we're simplifying, we want it to be fully simplified. And so we have to think of what we can pull out of this absolute value, and that would be positive numbers. And since 2 is positive, we know the absolute value of 2 is 2. So this equals 2. And x squared, if x was negative, negative squared is positive. And if x was positive, positive squared is positive. So it really doesn't matter what x is. X squared will always be positive. So we can also pull that out of the absolute value. So this is x squared. And we have a y cubed left to consider. If y is negative, y cubed is also negative. So we can't pull it out of the absolute value because in the end I want just a positive result. So that y cubed stays in the absolute value. And this is our final answer.